In this video, we'll discuss conditional flow control and build logic into our MATLAB M files. What we want to do is understand the concept of conditional flow control and how to use logical tests to determine which commands to execute. We do this through the use of the if, else if, and else commands in MATLAB. And then what we'll do is look at combining conditional and iterative flow control. Remember, iterative flow control we talked about using for loops to work with matrices and to implement more sophisticated MATLAB programs. So let's look at the basic structure for a conditional flow control. The idea here is to control which commands are executed based on the result of a logical test. So basically, the way this works is we say, if the logical test, if it's true, we execute one set of commands. If it's false, so else, that means it's false, we'll execute this set of commands. And then the end is required to end the block, the if block. Note the whole else side here, this is optional. So we could, as an option, just do something, one or more commands, if the logical test, for example, x less than 5. If that logical test is true, do a set of commands and then do nothing. We still need the end. Or if it's true, do one set of commands. If it's false, do another set of commands and then end. Let's look at how this looks on a flow chart. So here's a flow chart. We can see we're coming in. Here's our previous commands in our code. We come into the logical test. So here's the if statement. And we'll say if it's true, we're going to go this way and execute one set of commands. And then we come back down to the rest of the code. If it's false, we'll go this way, execute a different set of commands, and this is off the else statement. And again, this whole set, having an action to do if it's false, this is optional. It's not necessary. So here's an example of where you might use this, and that would be in adding error checking on function inputs to your M files. This is an example. I think this was from homework 4. This is a problem from homework 4 where you had to build a function that outputted 4 vectors, evens, odds, ratios, and up, down with one scalar input. And part of that function was that that scalar input was supposed to be a positive scalar integer, was part of that homework problem. So here I've just presented the solution to that problem again, but what I've added is a logical test to make sure that the input variable is a positive scalar integer. So here's the test. We say, is a greater than 0? So we're saying, is it positive? And I use the double and because a is a scalar. Does a equal round a? Again, from the previous video, that's testing, is this an integer? And length a equal 1. So here we're testing, is a scalar variable as opposed to a vector? If all of those are true, then we're okay. If any of those are not true, in other words, if any of those are not true, the expression inside the parentheses evaluates as false, and then I put a not in front of it because the if statement will only execute if the logical test is true. So the not is how we make the if statement execute when everything is false. We put the not there, so that changes it to true. And then what we're going to do is use an error command. This is a MATLAB command, built-in command. And that MATLAB command lets you output your own red errors to the command window. So down below we can see An example command window session using this function. Here's a negative value. Plugging in that negative value causes the logical test here to evaluate as false, which the not operator changes to true, which makes the if block execute, and that outputs the error. And so here you see the text. Input variable must be a positive scalar integer. That's the same text that we told it to output right here. Input variable must be a positive scalar integer. So this is a common practice to put error checking on your inputs to make sure they're in the required range for the use of your function. It doesn't mean you don't want to still put that information in your help comments. I left the help comments off of this just for space on this slide. So what happens if we have more than one condition? That's where we can use the else-if command. So if we have multiple selection criteria, so if we have one logical test, if that's true, we want to execute one set of commands. So if condition 1 is true. But if it's not true, we want to test a second condition. So if we see if condition 2 is true, then we execute a second set of commands. And then else, if all conditions are false, then we can execute a last set of commands. Again, that's optional. And we can have more than one else if. We can have as many else ifs as we want. So let's look at an example to see how this works. So here's an example called assignGrade.m. This is a function that assigns a letter grade based on an input score. So here we're using a standard grading scale, and we're going to say if the score is greater than or equal to 90, the grade's going to be an A. Else if the score is greater than or equal to 80, the grade's going to be equal to a B. Else if the score is greater than or equal to 70, grade is equal to C, and so on. Lastly, if it's not greater than or equal to 60, we get the else, and the grade is equal to F. Notice that because we're using the else if here, we don't need to say something if the score is greater than or equal to 80 and score less than 90. We don't need this to complete that test for the B grade. We don't need that because we're using the else if. The else if already determined that the score, this command won't even execute if the score is greater than or equal to 90. So we've already established that this condition is true. So we only have to figure out if it's greater than or equal to 80 before we assign the B, and so on down below. Let's just step through this in MATLAB and see exactly how these commands execute. Okay, so now we're in MATLAB, and I'm about to call the function with an input score of 83. So let me go ahead and hit enter, and we get that grade is equal to a B. Well, let's go over to the M file and put a breakpoint and call it again. So that's what we would expect. Let's call it again, this time maybe a score of 75, and we'll step through it this time. So here we are, we're about to execute the first. The score is 75, that's not greater than or equal to 90, so it should be false, and we'll see when we step that it jumps. The green arrow jumps directly to the next else if. And now is the score, which is 75, greater than or equal to 80? No, that's false. So again, we'll jump here to the next else if. Is the score greater than or equal to 70? Yes, that's true. So when we step, you'll see now we're inside the if block ready to execute that command, and we'll set grade equal to the string C. And after we execute that, you'll see now we're past the end. It will not even evaluate the lower conditions here because of the way the else if structure works. Once we find a value that's true, we execute those commands, and then we leave the if block, and since there's nothing else in this file, that means we're ready to leave the function. Okay, well, let's see what happens. Let's say we want to do a series of grades. So let's say we want to do grades equal assign grade, and let's try a couple. 56, let's say 89, say everyone did really well. Put in a vector here. 89, 92, 93, 65, and 78. So there's 5 grades. And we'll hit enter and we go here, and now here's our value. Score is now this array. Is it greater than or equal to 90? Well, we see that 2 of the scores are greater than or equal to 90, so they should get A's. So we'll step, and we see, oh, it evaluated as false. And here's what's going on here. It evaluates as false because for the if statement to evaluate as true, every element in the vector score needs to be greater than or equal to 90, and they're not. So we'll step again. Again, every element needs to be greater than or equal to 80, and we see the elements. We see 3 of the 5 are greater than or equal to 80. Here, every element is not greater than 70, so again, we're here, and now the grade is equal to a D. So everyone gets a D because one student scored a 65. That's probably not very fair, so we need to write a different function to do this, and we'll talk about how that works in a minute. But the bottom line is, for the if statement to execute, every element in this variable score, and in this logical test here, which is an array, a vector of 1s and 0s, every element must equal to 1. Or in other words, every element of score must evaluate as true with the logical test. So let's go back to the presentation and talk a little more about this. So I think flowcharts can be really useful to help understand exactly the programming flow when we're working with if statements, conditional flow, and also iterative flow. We introduced flowcharts when we started talking about iterative programming control. So what I want to do, and do this partly as a model for you, is to flowchart how this if-elseif-else statement is working, and then you might pause the video and try that once yourself first. So what we're doing is we're coming through, and we'll use a diamond for our test, and I'm just going to use an S for score. So we're saying, is the score greater than or equal to 90? Excuse me. So if that's true, then the grade is equal to an A. If it's false, I'm going to go here and say, is the score greater than or equal to 80? If it's true, our grade is equal to a B. If it's false, we go this way. Is the score greater than or equal to 70? True. Grade equals C. False. Is the score greater than or equal to 60? True. Grade equals D. False. Not another if statement. Grade is equal to F. And then what we're doing is all of these are joining together to complete and continue with the rest of the code, which in this case just is an end statement. So the other complication we saw here is, what if the logical expression is a vector or matrix? We saw that the if statement will only execute as true the commands that require a true result if the logical test is true for every element in the matrix. In order to make this work, what we're going to have to do is to use if statements along with a for loop to work through the elements of a matrix. Basically, the for loop, we can think of it as going to scan through the vector or matrix and apply the logical test to each element and act one element at a time. So here's another example of a time when we often need to use for loops. So here's how we can modify that grade assignment function to work. I've changed this to use numeric letter grade since we're going to be storing these in a vector. I don't really want to get into formatting the strings of letters in the vector. And so now I've changed the file name to assign grades. So notice the file name change and the function name change. So now what we're going to do is go in and here we pre-allocate grades. And we're going to output a vector of grades, and we're going to go in a for loop and using the length of the input to determine the number of iterations for the for loop, and then we put the same if structure inside here, but notice we're working one element at a time. So I'm using the index counter from the for loop to work one element at a time. So this is now a scalar. This is the single element of score. So this is a scalar that we're using in the if block. And in general, this is what you want to do, is to use a scalar to use your if statement, because then it's not going to be confusing with having to have every single element in the vector evaluated as true in order for these commands to execute. So what I'd like you to do is to step through this one in the debug mode with a vector of scores as an input, and try that one yourself. I think that'd be really valuable. Look at how this function builds this vector of grades. And now let's look at another example. This is a sign change counter. This example, which I have also uploaded as an M file for you to download and play with, counts the number of sign changes in a vector of numbers. Considers 0, positive, and negative as 3 different signs. So numbers, the input here is a vector, and basically the for loop, again using the length to define the number of iterations. Now it's doing length minus 1, because what we're doing is we're going through each way numbers. So the element times the next element. If that's less than or equal to 0, that tells us there's a sign change. And the second test right here is making sure that it's not 0 times 0. So if 2 subsequent elements are equal to 0, we want to make sure that doesn't add to the counter. And so now we just have a counter variable inside the for loop. So we come through and we test. First element times the second element, is that less than or equal to 0? If so, we're going to add 1 to the variable count. If not, we're just going to scroll through, go to the second element times the third element times the fourth element times the fifth element. Again, download this M file and try it out in debug mode. Scroll through and watch what's happening. So a question for you about this code. Can this code be vectorized? We talked about in the iterative programming video that it's a good idea to vectorize the code whenever possible. And the answer is yes. We can accomplish the same thing for this code as follows. And I'll do this in a couple steps. So one, we can create a vector called, say, products, and that's going to be equal to numbers 1 to end minus 1 times numbers 2 to end. So that statement is a vectorized version all at once of this first part of our condition, multiplying numbers of index times numbers index plus 1. So here we're doing that all at once. Then what we want to do is count. Remember, we can count by using the find command, or sorry, by using the sum command. So we can just say count is equal to sum of prods greater than or equal to 0 and now we need to think carefully about this other step. Numbers of index not equal to numbers of index plus 1. Well, again, we can use that same thing that we had here, numbers, and I'm just going to kind of scroll it down here, numbers 1 to end minus 1 not equal to numbers 2 to end. So again, here's two commands that do the same thing as the previous example, and that vectorizes this code. This is probably better than the previous approach, but the reason I'm presenting this example is for you to compare the vectorized code to the non-vectorized code and see what we're doing with this nested if statement inside a for loop and really understand how that's working. Also, the vectorized code really starts to demonstrate the power of MATLAB, of how we're doing something with two commands that required these two nested programming structures. If we were working in Java or C++ or another lower level programming language, we would not be able to vectorize this. We'd have to use that approach. Okay, so let's summarize. So we want to use if statements to add logic to your M files. That's the main goal in this video. We can use an if-in structure for single conditions, like error checking. That was the error checking example. If-else end if we have two conditions, or if-elseif-else end for 3 or more conditions. Often, but not always, we'll need for loops when using if statements to control command execution based on conditions involving elements in a vector. We saw that this is necessary for assign grades. .m, but not necessary for the sign change counter. So make sure you understand why it was necessary in one case and not necessary in the other case. And that concludes this video.